Hey guys, welcome to my channel. Today we are going to discuss reliable systems in system design. And trust me, this is the one of the most important topics if you want to understand how real world applications actually work. So let's start simple. When we talk about system design, reliability basically means how well a system continues to work even when the things go wrong. And in real life, things will go wrong, whether it's a server crash or a bug in a code or even a small human mistake. Instead of completely breaking, a good system should recover quickly and make sure user does not even notice the problem. Like imagine if your banking app or payment app stopped working every time there was a small issue, that would be a disaster, right? That's exactly why reliability becomes so critical. Now moving forward, let's understand what reliability actually means in a simple way. It's not just about whether a system works or not. It's about how consistently it works over time. A reliable system does not crash randomly, does not lose data, or does not even leave users stuck in the middle of something. For example, when you transfer money, you expect it to either complete properly or fail safely, right? But never get stuck in between. And that's what reliability ensures. It also includes something called durability, which means once your data is stored, it should not disappear even if something fails internally. So overall, reliability is about building trust between the system and the user. Now here is something important that many people confuse: faults and failure. So let's clear that up. A fault is basically the root cause of a problem, like a bug in the code or a hardware issue. But a failure is what the user actually sees. For example, if there is a bug in your code, that's a fault. But if the app crashes when the user clicks something, that's a failure. And the key idea here is that not all faults turn into failures, especially in design systems, because they can handle faults internally. And the main goal is to stop faults from becoming visible failures. Talk about the types of failures, because not all problems come from the same place, right? Generally we have three types, that is hardware faults, software faults, human faults. Hardware faults include things like server crashes or power issues, and the software faults are basically bugs in the code, and the human faults are the mistakes like wrong configurations or accidental deletions of data. And interestingly, human errors cause a lot of real world failures. So a good system should be prepared for all these types. Now to handle these problems, we use something called fault tolerance, which means the system is designed in such a way that even if some part fails, the whole system does not stop. For example, if one server goes down, another server should immediately take over, and this is usually done using redundancy. With the multiple components do the same job, so if one fails, other continues. And from the user side, everything should feel smooth without any interruption. Brings us to two very important techniques: replication and failover. Replication means keeping copies of the data on multiple servers. So if one server fails, the data is still safe on another server. And failover means automatically switching to that backup server when something goes wrong. And the best part is this happens almost instantly, so users might not even notice anything, and that's how big systems maintain high availability. So to wrap up everything, reliability is all about making systems dependable. We understood that what reliability means, the difference between faults and failures, the different types of faults, and how techniques like fault tolerance, replication, and failover helps in building strong systems. And the most important takeaway is that failures cannot be avoided, but their impact can be definitely be reduced with proper design. And if you understand this concept well, you will be able to design systems that people can trust and use without worrying about what's happening behind the scenes. Thank you.